We've graduated to larger things, such as the Arecibo telescope, 1,000 feet in diameter, with radio receivers, which are far more sensitive than we had 44 years ago. In fact, this telescope can duplicate all of that first experiment, all 2 months' worth of the observations, in about 1/10 of a second. That's all it takes. So you wonder maybe why did we do that? But you've got to start somewhere. Today we've graduated to the use of sophisticated computer electronics, which allow us to observe not just one channel at a time as it was in 1960, but rather today we observe 100 million channels at a time, and at Harvard there is now a system which can observe about 250 million channels at a time. And in our new system at SETI Institute, we will be observing 120 million channels at a time. This is a typical screen. Lots of noise. Each horizontal line here is 1 second's worth of data. You see a slanty line. That is the most distant intelligence signal ever captured. It was captured from the Pioneer 10 spacecraft, which is at the edge of our solar system, radiating a power of about 5 watts, about the same as a cell phone, from a distance of, we still observe it today. This was earlier, a couple of years ago. We observe it today at about twice the distance to Pluto, and still easily detect that signal. It just shows the power of the radio telescope to detect very faint signals from very great distances. What else might we be out there? Maybe creating greater longevity, greater L values, space colonies. Might it be that this is what we detect? Colonies in space radiating to their home planet, to other space colonies. It's things like this which we can only wonder about, things which can exist and which could create or maintain the visibility of civilizations for much longer time than we might presently imagine. It's even been hypothesized that there is a galactic internet of interconnected civilizations with their interconnected beams, transmission beams, shown here as a sort of a spider web of energy going across the galaxy. So, although we see our own planet perhaps becoming fainter, perhaps there are other things which keep civilizations visible. Things like this, perhaps solar power stations in space, who knows. We do need to do a great deal of searching, particularly in the radio. So far we have searched 150 light-year radius from the sun, and this diagram gives you a slight feel for how little of the galaxy we have actually looked at. We have looked at thousands of stars, and yet it is just a drop in the bucket. We have hardly touched the cosmic haystack. We want to move on now to 1,000 light years from the sun, several thousand. And to do that, we at SETI Institute are constructing a radio telescope just north of Mount Lassen in Northern California. It will use 350 small antennas using dishes as you see here. They're each 20 feet in diameter. Here you see actually 10 dishes nested together being carried from the manufacturing plant in Idaho Falls, Idaho, all the way to Northern California on this truck where there's this tilting bed because when you go under, it needs to be tilted like this to not be too wide for the highway, but it's now too high to go under underpasses. And so it has to be tilted up horizontal, and you have to bring the police and close the road whenever you go under a low overcrossing. And here are 2 of the dishes already in place at Hat Creek in this project, which is a joint project with between the University of California at Berkeley Radio Astronomy Lab and the SETI Institute. And here's some really happy people recognizing, hey, the dishes actually move and focus radio waves the way they should. And here's a picture with 3 dishes in place. And this is presently we're in the process of making a 32-dish array, but the eventual goal is 350 antennas in this system, which is called the Allen Telescope Array, named for Paul Allen, one of the co-founders of Microsoft, who has provided major funding to the project. This is what it will look like if all goes well and the funds are raised. We do not have all the funds in hand yet. This is what it will look like in the year 2007. And what we will use to continue the search. The search will go on at Arecibo. Arecibo cannot look at the whole sky, and in particular cannot look at the center of the galaxy, which is one of the more promising places. The Allen Telescope Array can look at the center of the galaxy and examine much more of the galaxy than the Arecibo telescope. The Arecibo telescope has more sensitivity, but the Allen Telescope Array will be able to look at some of the prime places in space. So where do we stand? We've learned that there were some things we were badly wrong about 44 years ago. We've learned a lot more about where planets can be habitable, and that there are far more than we ever imagined. And in all other respects, our assumptions or guesses 44 years ago have turned out to be roughly correct, and that in fact we can expect a very large number of detectable civilizations in space. So we should continue. If we do not search, we lose an opportunity to enrich the world with a wealth of new information, and we'll lose almost nothing in material value. It doesn't really cost a lot to carry out these searches, at least not in the grand scheme of things. Some people think it costs too much. This is just to say that's not true. The opportunities are too great. The potential benefit far exceeds any reasonable cost, which is, in any case is minuscule. If we do search, we may enrich knowledge and philosophy without bounds. It will cost us relatively nothing. All of SETI in the whole world costs only a few $1 million a year. Very small compared to other major scientific projects. And perhaps most importantly, scientists, like all people, have their dreams. We all need dreams of a better future, of accomplishing good things, of having a better life, and we will keep alive our dreams of learning of other intelligent life in space.